Good morning, everyone, and welcome to Fun with Numbers. In the past, we would have learned skills of reducing fractions to its lowest terms. For example, if we had 4/8, we would have had to look at a common factor. We would have said, well, these are even numbers, so 2 can go into 4 twice, and 2 can go into 8 4 times. And then we will look at our 2 and our 4 again, and we said 2 can go into 2 once, and 2 can go into 4 twice. And nothing could reduce again, and we said our answer will be 1/2. So what we are looking at here, we are revising how to form an equivalent fraction by dividing the numerator and the denominator by the same number. Now, I want us to consider that if we had look at it. We have a whole, and the whole is divided into quarters. And suppose I tell you I want half of a quarter. If I want half of a quarter, so this is a quarter here. This area here is a quarter right there, and I want half of that quarter. But you know when you are finding a half of something, you cut it into 2 equal pieces. So look at this. So I'm going to get a half of a quarter by cutting it into 2 pieces. Yeah? So I'm not talking about half of the whole, I'm talking about half of the quarter. And in looking at it, you will realize, what piece is this? Can you determine what is the size of this piece? That a half, 1/2 of a quarter is what piece? Okay, let's extrapolate it. Let's take this out here. Let's divide this here. Let's divide this here. Right? We would get 1, 2, 3, 4, 5, 6, 7, 8. We can say that a half of a quarter is really 1/8. Do you see that? That this piece here, which is a half of this quarter, is really 1/8 of the whole amount. Alright? Now, I want to remind you of the word of in mathematics, because we would have said that when we were younger children, we have, look at that. Well, we have how many sets? We have 3 sets of 1, 2, 2. And 3 sets of 2 would give us 6 altogether. And your teacher would have taught you in the past that sets of, another way of saying sets of, we can say I have 2 3 times. And you would have 3 times I have 2, which is 6. And we said, well, we are not doing English, we are doing mathematics, so we use the symbol times or multiply. 3 times 2, I have 6. Alright? And we always would have developed and established that of means we multiply. So when we are looking at a half of a quarter, we are really saying a half multiplied by a quarter. Okay? And look at what happened. You multiply the numerator by the numerator, and we got the numerator of the answer. And we multiply the denominator by the denominator, and got the denominator of the answer. Okay? So good. So when we are multiplying fractions, we can simply multiply the numerator by the numerator to get the numerator of the answer, and the denominator by the denominator to get the denominator of the answer. Alright? But sometimes we have to reduce the fraction to its lowest term, and we are reducing 4 ways. This way, this way, this way, and this way. 4 ways. Look at what I'm talking about. If we have 5 over 10 multiplied by 3 over 9. Look at that. Firstly, we try to reduce this way. Then we reduce this way. Then we reduce that way. And then we reduce this way. So 5 and 10. 5 into 5, 1. And 5 into 10, 2. Can this reduce again? No. So we go to reduce this way now. 3 into 3, 1. 3 into 9, 3. Okay? So this cannot reduce anymore. So can we reduce this way? No. Can we reduce this way? No. So now that we have checked our 4 ways of reducing, then we multiply our numerator by our numerator to get the numerator of the answer, and the denominator by the denominator to get the denominator of the answer. 2 3s are 6. Let's try another one. Suppose I had 80 over 100 multiplied by 120 over 150. Alright, this is easy, okay, because we see numbers ending with zeros, so we know that they are factors, right? A factor of it will be 10, so we divide by 10, and it's very easy to divide by 10. When we are dividing by 10, we just take off a 0, yeah? So look at this now. Can this reduce? Can the 8 and the 10 reduce? Yes. What can we use? The factor. The common factor is 2. 2 into 8, 4. And 2 into 10, 5. Let's look at this. Let's reduce this way now. Alright. So we divide by 10 here. Good. But we have 12 and 15. What can go exactly into 12 and 15? Certainly not 2, because 2 could go into 12, but 2 can go into 15, because 15 is an odd number. So we say 3, because if we find the sum of the digits, 1 and 2 is 3, and 1 and 5 is 6, and 3 can go into those numbers. So we can say 3 into 12, 4, and 3 into 15, 5. So this cannot reduce anymore. So now we try this way. We try this number with this number. 4 and 5. Can it reduce? No. What about 4 and 5? Can it reduce? No. And do not ever make the mistake and reduce a numerator with a numerator, because that is not what we had learned in our previous video. In our previous video, we had learned that we form equivalent fractions by multiplying or dividing the numerator and the denominator by the same number. And children normally get excited and they would cancel this 5 with this 5, and they will cancel this 4 with this 4, and that is not the case. We are looking for a common factor to go into our numerator and our denominator. So as in this case now, since we have divided this way, this way, this way, and this way, these 4 ways, and nothing could reduce again, then we simply multiply the numerator by the numerator to get the numerator of the answer, and the denominator by the denominator to get the denominator of the answer. Good. So if you would have done that, then you would have learned how to multiply fractions. So let us recap. We would have said that the whole idea of multiplying fractions would have come from when we are talking about finding a fraction of another fraction, or sometimes we have to find a fraction of a quantity. We would have had a whole, and the whole was divided into quarters originally, and we wanted to find out 1/2 of a quarter. And I would have used the fraction model here to show you that if we have a quarter and we want to find a half of the quarter, we would end up with really 1/8 of the whole. 1/8 of the whole. So as we look on this side here, we would see that sometimes we may be asked to find a fraction of a quantity. Suppose you had $150. If you had $150 and I want to know how much is 2/3 of your money. So I can say I want to find 2/3 of, remember, of means multiply, 2/3 of $150, and I just put it over 1 because we just put a little placeholder 1 here, because any number divided by 1 will still give you the number. So 150 over 1 means 150. Okay? So we just put it over 1 so we will be able to see, we will not get mixed up, right? So we will establish that 150 is our numerator. So can we divide this way? No. Can we divide this way? No. But what about this way? What about 3 and 150? If we find the sum of the digits in 150, 1 and 5 is 6. And 3 could go into 6, so we know 3 could go into 150. So we say 3 into 3, 1. 3 into 15, 5. And 3 into 0, 0. So we just don't leave our answer there. Remember, we have to go this way. We have to multiply numerator by numerator. 2 times 50 will give us 100. 1 times 1 is 1. And how much is 100 over 1? Any number over 1 is the number itself. So the answer is, you would have had 100. 2/3 of $150 is $100. Okay? So let's try one more. Let's try one more before I send you a worksheet. Okay? Suppose your weekly allowance is $200 and you spend 3/4 of your weekly allowance buying snacks. So let's find out how much money you spend buying snacks. So you would have spent 3/4 of the $200 buying snacks. Okay? Nothing could divide this way, nothing could divide this way. So we said, what about 4 and 200? 4 into 4, 1. 4 into 20, 5. 4 into 0, 0. And 3 times 50. Remember that skill I taught you? When we are multiplying by numbers ending with 0, you simply block the number and you multiply. So 3 times 5 is 15. And you add back your 0. And you will have spent $150 buying snacks. So, until another day, I will send you a worksheet and you need to practice. You need to practice where you are multiplying your fractions. So until then, so long.